How's everybody doing today? Good? Awesome. So I wanted to get like a quick survey. How many of you have actually developed mobile applications? Show of hands. Oh, good. And how many of you have done used Go in some capacity with developing mobile applications? Oh, wow. Well, embedded, Go inside the mobile app, doing some type of work. Okay, cool. All right, so I guess we'll talk about that today. So a little bit about myself. I'm the founder of a company called Wirecog, and we happen to be completely a Go shop. And we created the open source Isomorphic Go project. And we have experience consulting in Go, and we've done some stuff we've done consulting for 3 Fortune 100 companies. I happen to be the author of the Isomorphic Go book, basically taking modern web application development techniques and bringing that over into Go. So today I'm going to be talking about the first mobile app I developed. And when I wanted to jump into mobile development, I wanted to bring Go along with me because I'm so enthusiastic about Go. And everybody was telling me, you know, there's a tool called Go Mobile, and they were saying, don't use Go Mobile. It's experimental. You don't want to use it. You can't do production code with it. Just stay away from it. But I was just hell bent on saying, hey, I want to use Go and I want to make an app. Over the course of 2 weekends, I was able to develop an iOS app with Go Mobile and Gopher.js, which Gopher.js is basically a tool that transpiles Go code to JavaScript. And basically what I was able to do in the course of 2 weekends, I was also able to port over to Android, and I was able to take about 85 to 90% of the Go code and basically take it over to the Android platform without having to modify it. And so that's the subject of the talk today, is basically the making of this app, how I went about it, and just sort of like the way that I structured it and stuff. So first off, like, why would you even use Go for mobile development, right? Like someone said, hey, it's server side, right? First off, I want to say that it has a robust standard library, and I'm talking like the networking package, the math package, just string manipulation and date and time formatting. Multi-threaded programming, it's more straightforward with Go routines. And like I said before, so the Go mobile tool, you could actually use that to compile your Go code to a native library. And you can use Gopher.js to basically transpile your code to JavaScript. And most mobile apps these days, with the advent of hybrid apps, you're basically running a web view object within your mobile application. And what the web view object is it's basically an embedded web browser that basically renders a web page, and you pass that off as the UI basically. So yes, Go can be used for UI programming. And because it's cross-platform, again, you've got this incentive where you could actually take that code and migrate it to a different platform. So talking a little bit about the design of this app, this is called the GolangAce App, and it's basically a virtual assistant, just a very simple chat bot that answers common Go questions. And it does stuff like it provides answers in the form of like trivia. It provides basically standard package info and also code examples. And again, 85 to 90% of this app is cross-platform because it's written in Go. And it's using Go for both business logic and the UI. And the really tricky thing about making an app that's a hybrid app where you're using web technologies is that you don't want the user to feel like it's a web page. You want them to feel like it's responsive, it's fast, and the flow is fast. So taking a look at the wireframe, this is basically the user interface screen. This is the main question screen. And if we can think of a mobile app as a collection of features, and a feature being a collection of flows, the flow that we're going to discuss today is basically, well, the user asks a question, and how do they get the answer back? And we're going to go over that flow and see all the different ways that we call Go to make that magic happen. Call Go and also call the native layer. So let's go into the setup, the stuff you need to get started developing a mobile app with Go. We have a Go-based REST API that's basically sitting on a really weak cloud compute instance, but that's not the subject of the talk because there's been a lot of talks about that already. So our talk is going to focus on the bottom portion of that list, starting with Go Mobile. And as I mentioned before, Go Mobile is a tool that basically takes your Go code and it will convert it to a native library. So if you're on iOS, the output will be an Objective-C framework. And if you're on Android, you'll basically get an Android archive file. Gopher.js, it produces JavaScript. And the reason that JavaScript is important is we use Go as a tool to both manipulate the UI and also handle user events from the UI. And because the web view includes a built-in JavaScript engine that can basically that can basically run JavaScript, that's the reason why we need Gopher.js to convert that over. Because we don't want to write JavaScript, then that would be no fun. This is a Go talk. You need Xcode to develop iOS apps, and you need Android Studio to develop Android apps. And you need plenty of devices to test with. So getting Go Mobile, you just run that go get command, and then you simply initialize it with Go Mobile init. And Gopher.js, pretty easy to set up also. Just go get Gopher.js. And when you're starting out in Xcode, what I would recommend is starting out with the single view app template. And the idea here is that the less boilerplate code you have, so if you pick a really complex template to start off with, you're going to have more complexity. So it's better to start simple and build your way up as you need more capabilities and features. Then you basically add that onto the native layer later. And same deal goes for Android Studio. You create a new empty activity template. And let's talk a little bit about the architecture now. So I like to kind of divide the app into areas of responsibility. And so in green, we've got the user interface. As I said before, what happens there is that Go code gets transpiled to JavaScript. And its sole responsibility is basically to manipulate the UI. So for example, once the user hits the Go button to get an answer, we'll display the answer screen. Or if the user hits the help button, we'll display the help screen. And also on the user interactions, when the user touches the screen, we also want to get touch events and handle them. So that layer in green basically handles that magic. The application layer, this is the native layer. If you're in Android, this is where all your Java or Kotlin files lives. And if you're in iOS, this is where Objective-C and Swift files live. The important thing about the application layer is that capabilities that are inherent to your device, like 3D touch or in-app purchases, the application layer is important for that. All of the stuff that makes the particular device unique as opposed to the other platform. In blue, we got the business logic layer, and the business logic layer, again, that's also implemented in Go. And the idea is that this is the logic that's unique to your application, or you can think of it as domain logic. And it's basically the logic that you can take wholesale from one platform to the other without modifying it. And the key here, in order to make this happen, to make this strategy happen, is you got to be as vendor neutral as possible with your Go code. And so you have to look at your Go code, and you can't call, for example, you can't call native functionality that only works on one platform and expect it to work on the other platform just because you called it in Go. So you just have to make that distinction there, draw a line in the sand, and make sure that the code that you're writing is platform agnostic. And then finally, so the business logic, the app actually does a little optimization on the question. So it actually does some number crunching. And we have a really cheap cloud compute instance. We want to save money. So we actually do some processing on the mobile device itself. And that, using the Go Mobile tool to basically generate that native library for us and run that as machine code, it really helps us. And so the business logic layer is also responsible for shooting out the question to the REST API endpoint. and then getting the result back and reporting it to the application and native layer. So what does it take to build mobile-friendly Go code? It's actually pretty easy. It's just a simple command here to build your business logic layer. You just run go mobile bind, and you provide a target. And pretty self-explanatory. For iOS, it's iOS. For Android, it's Android. Go mobile comes with a couple type restrictions. So after the talk, when you go through these slides, just read some of these links about the type restrictions and stuff, because you don't want to tie yourself up. You want to know full well what it can and can't do before you swallow the red pill. So on the UI side, again, like I mentioned before, Go gets transpiled to JavaScript. And it's a simple command because you're generating minified JavaScript. This is JavaScript that both will run on iOS, and it's going to be running on Android as well. As far as code organization is concerned, so what we're looking at here is a screenshot in my Go path, and in the source folder, the SRC folder, you've got two sets of code bases starting out. You've got the code base where your Go project lives, and you've got the code base where your mobile development project lives in Xcode or Android. And so GolangAce inside GoPath/SRC, I've got three important subfolders there. One is the ACE subfolder, and that's where the business logic lives. The client folder is where the UI code lives. And the static folder, again, what we're doing is we're basically rendering a web page, and we're passing that off as a UI. So the static folder basically has that GolangAce.html file, and that HTML file basically gets rendered, and it contains all the different screens, all the different user flows that the user can interact with in the application. And that JS folder, the empty one that's all the way down there, the minified JavaScript, once we run the Gopher.js build command, we basically put the minified JavaScript in that folder over there. Once you produce like the framework, the Objective-C framework, or the Android archive file, you actually drag and drop it into your Xcode or Android Studio project. And if you're doing iterative development, so you're basically coding in Go, you run Go mobile bind and you produce your library, you'd come back and you'd actually you'd right click, you'd delete the framework, you'd go back, Go mobile build it, ace.framework is regenerated again, you drag and drop it in there, go to work. And similarly, notice that I have the static folder there, and the static folder contains the GolangAce.html file, which is the UI. And there you see the minified JavaScript in the JS folder. And the minified JavaScript was produced with the Gopher.js build command. Same deal goes with Android. The only difference is we're dealing with Java files instead of Objective-C files, and you're dealing with an Android archive as opposed to an Objective-C framework. So the web view is really the main star when it comes to user interfaces, because again, the web view allows you to pass off a web page as a UI, and I'm going to show how we set up the web view both in Objective-C and in Android. So starting with Objective-C, we first have to implement the WK script message handler and the WK navigation delegate interfaces. So the WK script message handler, we need that because what we want to do is we want to have in JavaScript land, in the UI land, we want to be able to pass user events over to the native layer. And that's our mechanism. We pass it through messages, and we post messages to the native layer. WK navigation delegate, so basically also when we create a new web view, remember this is an embedded web browser, and we want to have the fine-grained granularity to actually be able to control the user interactions. So the worst case scenario is if the user, like you have a link in your web view, the user hits it, and then it opens up in a web browser, and that's what you weren't anticipating. You wanted to render a user interface for the user. You wanted it to basically get control of your user interactions. And finally, we define properties for the WK Web View object and the WK Web View configuration object. The web configuration object helps us set up the web view. Initializing the WebView configuration object, it consists of creating a user controller. And here, what's important about this example is that we're registering the ask question user event to the user controller by calling the add script message handler method. And then after returning the web configuration, we actually initialize that web configuration. When we initialize the web view, we use that web configuration. And finally, in the viewDidAppear method, we're loading the HTML at the very end. That's what the load HTML method looks like. We basically take the GolangAce.html file and we render the UI. And if we were to open the GolangAce.html file in a web browser, that's what it would look like. We'd basically get the gopher and the yellow background. And as you can see on the right, that's just basically HTML and CSS in a web browser. And in Android, so again, Android has its flavor of the WebView object. We called the load HTML method in Objective-C, whereas in Android, we're calling the load URL method of the WebView object to basically do that same exact thing and load the UI, the GolangAce.html file. OK, we basically set up the WebView for the application. Now we're going to go through that flow, right? Circle back right in the beginning where we went from question. How did we get from the question to the answer? And so starting out, let's say the user hits that go button. What ends up happening is it calls this event handler function. And the very first thing, one of the first things we do in this function is we display the loading screen. The loading screen, we have a little spinner going, indicating that we're doing some work. And then we call the ask question function within the UI layer. And the ask question function basically takes the event and it posts the message to the native layer. And it basically uses the window.webkit.messagehandlers object. And remember, in the user controller, we had basically registered the ask question event. And that's the mechanism that allows us to pass this message over to the native layer. On the native layer, once we get that message, we basically call the business logic layer, and we call the ask question function that exists in the business logic layer. And then we basically get the answer, and we call the display answer function in the UI layer. And in Android, this is how we basically do that exact same thing in Android. And inside the business logic layer, that ask question function, this is like typical Go code of basically using the HTTP package to make a request out to a REST API endpoint and getting the response back and returning it. And again, once we got the answer, the response is going to be the answer. Once we get it back, we call the UI, and we call the display answer function in the UI. And like I said before, again, we're using Go to manipulate the UI. So we call the display answer screen function, and we provide the answer, which will basically show the answer on the screen. So I guess now it's time for a demo. I don't know if everybody can see this. If you want to huddle like a little closer, that's cool too. So I'm going to hit the button to load the app, and what is a channel?
Channels are the pipes that connect concurrent Go routines. You can send values into channels from one Go routine and receive those values into another Go routine.
Describe package math.
Package math provides basic constants and mathematical functions.
Show me how to declare a slice.
Slices are a key data type in Go, giving a more powerful interface to sequences than arrays.
So basically, as you can see, it's pretty fast. This is over a 4G connection, but I have a really wimpy cloud compute instance. I'm not paying that much for it. And the idea is that the mobile processor, you've got a computer sitting in your hand, and take advantage of that. Don't just throw everything on the server side. There might be optimizations or work that you could do on the client side as well. And before we wrap things up, I wanted to share some war stories or preparing you guys for the app review process. And number one, I got to say it's not that bad. Reading things online, there's a lot of horror stories out there. But really, what I found was just go through the App Store review guidelines and just go through each of the sections. And one thing I can't stress more than enough is test on actual devices. The simulator will get you so far, but if you're not testing on actual devices, you never really know. And finally, I wanted to mention that adding extra capabilities to your app, that increases your testing complexity. And what I mean by that is if you're going to add features like 3D touch or in-app purchases or location-based methods, you're going to have to also do the work to test for that. So know that beforehand, before you actually go into it, before you take the dive. And also, if you have any feedback for the GolangAce app, I always appreciate community-based feedback, so it's much appreciated. Thanks.
Mm-hmm. Having your Go code rewritten to JavaScript, what was your impressions of the efficiency and accuracy?
That's a great question, because we actually did do an exercise where when we send the question over to the REST API endpoint, there's some optimizations that we make on the question to make it more machine friendly. So it's not like an English question going into the REST API. And what we found was we first actually wanted to see, well, why don't we try doing this first at the Gopher.js, with Gopher.js build, and doing this at the UI layer. But one thing that you have to understand with JavaScript is that more often than not, JavaScript is running in a single thread. So even though Gopher.js supports Go routines, you're still constrained with the fact that JavaScript's running in a single thread, and we found it to be very slow. So that same like Q&A flow that you saw, it would take a couple more seconds to do that in Gopher.js. And also, the risk that you run is you don't want it to freeze your UI. So the interactivity, again, you don't want the user to know. The secret with this whole thing is you don't want the user to know that that's a web page that they're actually interacting with. So the minute that you tax that layer, that interactivity, that the responsiveness goes away, basically.
Is that one of your reasons for saying tested on physical devices versus virtual devices? Exactly.
And what I found was, for example, on my Samsung Galaxy Tab, I found that it was 30% slower than my iPhone, but there's many factors behind that. At first, I was quick to judge and say, hey, this is running in Java, it's interpreted code. Of course, it's got a just-in-time to compiler, and maybe that's why I'm seeing a 30% drop in performance. But also, the other thing is maybe the Samsung Galaxy Tab's processor isn't as efficient as the iPhone XS processor is for that same type of workload. Of course, I didn't dig into the guts of it and see what was actually going on. I was satisfied with the performance enough that I was like, okay, this is bearable.
How readable is the JS that gets transpiled?
That's a great question, and it's not human readable. It's not meant for humans. It's meant for machines. And of course, you can tinker around with it, and it's actually fun to read both the minified JavaScript and read the map. The map file helps you basically get from the minified back to the Go. So it's actually cool. Gopher.js is, I'm a big fan of that project because it's a really Herculean engineering effort to have pulled that off. Of course, in the future, to kind of future-proof you guys, in the future, it's moving towards WebAssembly. So instead of Go, into JavaScript, you'd have a target to WebAssembly. But if you needed to release an app this quarter or something like that, then Gopher.js, and you wanted to use Go, Gopher.js is probably going to help you out.
How did you run into any difficulties around iterative development, making tweaks, of a build, making a tweak? I mean, how's that?
Surprisingly not, and that's what made it so fast and fun. When it came to the UI layer, what your iterative development cycles look like there is basically running Gopher.js build and making sure that's working, and you could use a web browser for some flows, but other flows require the full setup. Other flows will require you to basically run that through Xcode or run that through Android Studio and get that working first. And I always connect my device because I'm always testing on my device as opposed to testing with the simulator. On the business logic side, that was a lot more faster than the UI side. But overall, it was more pleasurable to be developing using Go because for one example, reachability. There's a reachability API for for iOS and a reachability API for Android. And what reachability is hey, is the network connection available? Am I able to make a call out to a server? Well, guess what? Again, going back to the Go standard library, Go excels at stuff like this using the net package. And what was super cool was just seeing that I could write my own reachability, a really simple reachability function, and I didn't have to go searching for third-party libraries or adding more cruft to my code, basically.
What would the testing story be like in terms of Go test for Go4JS? Comment on that.
There's a link on the slides. So when we send the slides out, I actually got a link on the Gopher.js guide, and they use Node.js. So there's two ways to set up Gopher.js, and the way that I've shown you to set up Gopher.js is basically the really simplistic way, and the other way is to use Gopher.js in conjunction with Node.js, where you also have the suite of JavaScript tools to bring along with you to test UIs and stuff.
I've got a question about some trickier, native libraries or native tools you might have to use in applications, whether it's you mentioned 3D Touch for iOS, or if there's an Android-specific library you wanted to use. Do you have any experience with either Gopher.js and Go Mobile, and are there any facilities to interact with those native-specific, independent libraries?
Great question. And basically, Go Mobile also provides another facility. So basically, the basic functionality which this app used, the GolangAce app used, was Go Mobile Bind. And Go Mobile also provides a facility called reverse bindings. And the idea behind reverse bindings, instead of native calling Go code is calling native. And so, for example, for 3D Touch or for some of those other pieces of functionality, however, unfortunately, the reverse binding portions are more experimental. And the idea is the minute that you start calling from Go the vendor-specific stuff, you're basically locked in on that platform. So you can't basically drag and drop your Go code over to the other platform without modifying it. But it is possible, but it's not as prevalent as Go Mobile bindings. Any other questions? Thanks. Take it over, Michael.